Hi everyone, welcome to Not So Nerdy channel. Today is the 6th day of solving NeetCode 150 questions with me. We are on the 11th question, which is based on container with most water. So I'm skipping one question from each of the topic because by the end of completing our sheet, I want to revise these topics again. So we are going to solve those questions in the last week of NeetCode 150 questions, okay? So that we could just revise the 2 pointers, arrays and hashing again, and the other topics as well, okay? So today's question is container with most water. You are given an integer array height of length n. There are n vertical lines drawn such that the two endpoints of the ith line are I, 0 and I, height of I. So we have an integer array height of length n. So here we have the length as this. This is our length. Okay. And there are n vertical lines drawn such that the two endpoints are of the ith line. So let's say that we are taking the second line. So here our two endpoints will be the I of the second line is 1. So 1, 0 and 1, 8 because height is 8. So these are the two endpoints. Find two lines that together with the x-axis form a container such that the container contains the most water. Return the maximum amount of water a container can store. So here, according to the example, they have already given us the input height and the and drawn the blue portion which represents the output because the maximum area cover is 7 into 7, which is 49. Similarly, for example 2. So how are we going to approach this question? So we need to get the maximum height. Now, first we will see that, okay, first we have to see that suppose this is our first index, which is 0. Now this has a height of 1 and our second vertical line has a height of 8. Now we will see that the area of water which can be stored here is only this much. Otherwise, it will spill out of the container. So it's going to take the minimum of both the vertical lines and then store the water. So it's going to be 1 and the distance is 1. So 1. Similarly, for second, it's going to be 1 height and 2 distance. So 2. Then 3 distance, so 3, so and so on and so forth. So next we are going to move on to the second second vertical line. So second vertical line, yeah, it has a height of 8. Now we check that our right line has a height of 6. So we are taking the minimum, which is 6, and the area is, the distance is 1. So it has a 6 area. Okay. Next we can take this, the fourth vertical line, and it has an area of 2. 2 is the height and the distance is 2, so 4. So that's how we are calculating the areas, right? Okay. So for this we need to see that we have two sides, like the left side and the right side. So for the brute force approach, we can take 2 loops here. So let's say for L in range length of height. So we are going to take our left side till the last of the vertical lines. That is why the range is length of height. Then we are going to see for the right side. So for R in range. So our range of right side is ranging from left plus 1. We are always going to have that the right side is always greater than the left side. So we are checking the next I'm sorry about using the word candle. We are going to check the next vertical line. Okay. So left plus 1, comma, length of height till the, okay. Let me just, okay. Now we need to have the area. So area will be equal to, so for each two lines, we are having the minimum of both the lines. So it's the height will be the minimum of both the lines. So it will be minimum of height of L, comma, height of right, multiplied by the distance, which is r minus L. Okay. Now we need to check that what the result will be. So result should have store the, okay, let's initialize. Here we need to initialize the result by 0 so that we can make the comparisons and store the maximum of result and area. And finally we will return result. But this is not it's a valid solution. Did I? Sorry, because of the bracket. Okay. So it's gonna be a valid solution, but it's gonna exceed the time limit. Let's see. Yeah. So our time limit has been exceeded. So it's a brute force approach. That's why we need to come up with another solution. So we need to think of a different approach to solve this question. Initially, we had index on the first one and the second one, and we were looping twice to get our answer. But instead, how about we shift our right pointer to the last one? That way we can directly compare that, okay, this is our initial area. Then we will store it in some max area or something. Then we can just simply think about, okay, so now we need the maximum capacity, right? So we will check whose height is less. So the left hand side height is less. So we will shift on to the next index, and then we will check whose height is less, and we will calculate the area accordingly. And this will give us 49. Okay. So similarly, now we have the right hand side's index, right hand side's vertical line's height is less. So we will shift on to the previous vertical line that gives us this much area. Similarly, now we again shift it to the next, and then we come at the same height. On coming at the same height, we will simply calculate our areas and store it, and then we can either shift the right side or the left side. Both will be the same. Now we will have to like both can be possible. Now we might think that this has more area, but we can see that its distance is 5 and the height is 8. So our value is 40, which is clearly less than 49. So that's how we will keep on storing our area into max area and make comparisons to get a result. Okay. So for this new approach, we will have to, instead of this, we'll have to start. Okay, wait. Right. We're gonna use the same formulas, right? So I'm gonna keep it. Okay. Now suppose we have left index at 0, right index at length of height -1, and we are going to keep an max area to 0. We are going to initialize our max area to 0. So while left side is less than right side, we'll have to first calculate the area. So for area, we can simply use the same formula which we used in the brute force approach. Let me, okay. Okay. So it's the same. We are first going to check whose height is minimum, and that multiplied by the distance between the right index and the left index. So that will give us the current area. Okay. Then we will store our max area in by using the max function. So max area comma the current area. Okay. Now, if height of left, as we saw, height of left is less than height of right, we will get left, we will increment the left index by 1. Otherwise, we will increment the right index by 1. Okay. And obviously, if both the heights are equal, then 2 we can decrement the right index by 1. So we are decrementing our right index in both the cases, and if height is less than height of right, we are incrementing the left index by 1. And finally, after all this, we will return our max area. Okay, so let's try running this. I'm gonna delete it. Okay. So this is a more efficient method to solve the question, and feel free to ask your doubts and connect with me on LinkedIn and Instagram. Thank you.